Welcome to question 1 of the 2018 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for part A of this question we have if y equals negative 3x cubed plus x squared minus 64 all cubed, find the derivative to y dx. Now if we inspect this rule here, we can see that it is a function inside a function, so we're going to require the chain rule. And to apply the chain rule, we're going to identify y is equal to some inner function u cubed, and that inner function is negative 3x cubed plus x squared minus 64. And just be careful when you're rewriting this out, just so that you don't make any errors. Then we're going to calculate dy du, which is equal to 3u squared, and du dx, the derivative of the second inner expression, which is going to be minus 9x squared plus 2x, and the negative 64 would differentiate to 0. Now from our formula sheets we know that the chain rule, which calculates dy dx, is equal to dy du multiplied by du dx. So therefore dy dx, which is what we're asked to calculate, is going to equal dy du, which is 3u squared, but u was minus 3x cubed, plus x squared minus 64, and that's 3u squared. And we're going to multiply that by du dx, which is minus 9x squared plus 2x. So that is the answer to part A of this question. From the examiner's report we can see that 58% of students got the mark, and students were generally able to recognise the need to use the chain rule. However, a significant number of students could not be awarded the mark, and that was due mainly to poor use of brackets or lack of brackets that resulted in an incorrect expression. For example, the expression that we needed is not equivalent to this expression shown here, where the brackets are missing. Transcription errors, especially with exponents, and arithmetic errors with unnecessary expansion were also observed in this exam. For part B, we now have the function f of x equals e to the power of x divided by cos of x, and we're asked to evaluate f dash, the derivative, when x is equal to pi. So this here is a function divided by a function, so we're going to use the quotient rule. And to apply the quotient rule, we're going to let u equal the function on the top line of the fraction, which is e to the power of x, and v is going to equal the function in the denominator, so that's cos of x. And then we need to calculate du dx, which e to the power of x derives to e to the power of x, and v dx is going to be cos goes to negative sine of x. Next we can see from our formula sheet that the derivative d dx of a function u divided by v is equal to v times du dx minus u times dv dx, all divided by v squared. So therefore, for this question, f dashed of x, just the derivative to start with, is equal to the function v, which is cos of x, multiplied by du dx, which is e to the power of x, minus the function u, which is e to the power of x, times dv dx, which is minus sine x. And then that is all going to be divided by v squared, which is cos of x squared. Next we need to evaluate the derivative f dashed when x is pi. So we're now going to substitute pi in wherever there's an x. So here we will have cos of pi multiplied by e to the power of pi. And then the two negatives here that are multiplying together actually give a positive, so we're going to have plus e to the power of pi times sine of pi. And then on the bottom line we're going to still have cos of pi squared. And now remembering your exact values for the circular functions, we know that cos of pi is simply equal to negative 1, and that sine of pi is equal to 0, and on the bottom line this cos of pi is also equal to negative 1. So therefore f dashed of pi is going to equal negative 1 times e to the power of pi, which is negative e to the power of pi, and then e to the power of pi times 0 is just plus 0, divided by negative 1 squared. And now that simplifies just a little bit further to be negative e to the power of pi divided by 1, which is just negative e to the power of pi. So that is the answer to part B of this question. From the examiner's report, we can see that 51% of students got full marks for this, while 40% got 1 mark. And the examiner's report goes on to say that students competently applied the quotient rule, however many were unable to carry out the required evaluation, and often they didn't do it at all. Students who opted to use the product or chain rules, which were possible in this case, tended to make little progress due to confusion with negative signs or negative exponents. Students should take care with legibility, for example, distinguishing clearly between a variable x and a constant, which was pi in this example.